Okay, this is number 4 on 7.3. So in this problem, you are trying to maximize revenue based on spending X thousand dollars on radio advertisements and Y $1,000 on newspaper advertisements. And you're trying to figure out X and Y to maximize revenue, okay? So you need to find the critical value because if there is a maximum, it's going to occur at that critical value. So we need both first partial derivatives. So we've got Rx here. In computing Rx, you treat y as if it is a constant. So the derivative of negative 0.06x squared, for that you bring the 2 down to get negative 0.12x to the first. The derivative of negative 100y squared is 0. The derivative of 4x is 4, and then 3y is also 0 because y is like a constant. Then for the derivative of 4xy, both the 4 and the y are being treated as constants. So the derivative is that coefficient, which is 4y. Right there. Okay, and then you compute Ry, which is computed a similar way. And then the critical value occurs where both of those equal 0, which in this problem gives you a system of linear equations. So I've labeled this equation 1, and this is labeled equation 2, just so you can follow through the work a little bit better. Okay, so there's a couple ways you could solve here. You can add the equations in such a way so as to eliminate one of the variables. You could solve one equation for one variable and substitute that into the other. Or a method that I doubt anyone would do is you could also use matrices. But I'm going to use elimination. So what I've decided to do is try to get these coefficients of the y's to be the same. So I'm going to multiply equation 1 by 50, which I've done right here. Negative 0.12 times 50 is negative 6. 4 times 50 is 200, and 4y times this 50 here is 200y, and 0 times 50 is 0. The second equation, I haven't done anything except reorder the terms. I put the 4x term right here first, the 3 in the middle, and then the negative 200y over here on the end, so that when I draw a line and then add these two equations, my variables are lined up correctly. So negative 6x plus 4x is negative 2x, 200 plus 3 is 203, and the y terms cancel. So then we have an equation just with x's, which we can solve, and we get x is 101.5. So then we need to go find what is y when x is 101.5, and you can use either of these two equations to do that, but I've used equation 1 and plugged in x is 101.5 right there, and I had to use 2 lines because I ran out of space right there. Negative 0.12 times 101.5 comes to, plus 4 comes to negative 8.18, which I've then moved over to the right side of the equation and solved that for y to get 2.045. But remember, x and y are in thousands. Okay, so in the end, you're going to need to move that decimal over 3 places. Okay, but first you need to make sure that there's actually a max at this critical value and not a min. So to do that, we use the second derivative test and the d test. Okay, so to compute d, we need rxx, ryy, and rxy. Rxx is the second partial derivative, so it's the derivative of Rx with respect to x. So we treat y as if it is a constant and x is a variable. So the derivative of this first term is negative 0.12, which is right here. And the derivatives of both the second and third terms are 0. Ryy is the derivative of ry with respect to y, so it's just negative 200. And rxy is the derivative of rx, but now with respect to y. So we get 0, 0, and 4. So then we have the information here to compute d, which is rxx times ryy minus rxy squared, which I've done down here. Here's rxx times ryy minus rxy squared. It comes out to a positive number, so when you go look at the d test, let's see if I can click on it correctly here. There it is. Okay, the d test says if d is greater than 0 and fxx is greater than 0, then you have a min at your critical value. Or case 2, if d is positive and fxx is negative, then you have a relative max. And that's what we're hoping we have here, which we do. D is positive and rxx is negative, so that means there is in fact a maximum at the point 101.5, comma 2.045. So we need to move those decimals over 3 places. So that means we need to spend $101,500 on the x. X represents radio advertisements, the amount of money spent on radio advertisements, and Y represents the amount of money spent on newspaper ads.